Hello, this is Dr. Hena Asil, and we are doing a chapter on air and air pollution. This is for the IGCSE Chemistry Edexcel syllabus. So, the first thing you should know is the composition of air. You should know that air is mostly nitrogen, so nitrogen is 78% of air. Then we have oxygen, which is 21%. Argon is 0.9%. Carbon dioxide gas is 0.03 or 0.04%. And water vapor is variable. So you need to know that if we say name the elements found in air, the elements found in air are nitrogen, oxygen, and argon. Name the compounds found in air, it's carbon dioxide and water vapor. So we can use air to obtain nitrogen and oxygen. So if we say where do we obtain nitrogen or oxygen from, we get it from air. How do we do that? We do that by fractional distillation of liquid air. We know that air is a mixture of gases. So if I cool it under pressure, it becomes a mixture of liquids, and we can do fractional distillation to obtain nitrogen and oxygen. What do we use oxygen for? Please don't say for breathing. We never say for breathing. Because when we talk about uses of oxygen, we're actually talking about large-scale industrial uses of oxygen. So you should say, for example, we use it in oxygen tents in hospital, or for oxygen cylinders for divers. Or we could say that we combine it with a gas called acetylene. When oxygen is combined with acetylene, it forms a flame that has a very high temperature, and this is used to cut and weld metal. So one of the uses of oxygen is cutting and welding metals. Now, this is an experiment that you will see a lot. He uses this experiment to determine the percentage of oxygen in air. So we put copper wire in the tube in the middle, and we have syringes on both sides that have a certain volume of air that we're starting with. We heat the copper and we push the air over the copper. Of course, the copper wires will react with the oxygen to form copper oxide. You should know what the color change should happen here. The copper wire is reddish brown, and when it reacts with oxygen and forms copper oxide, the copper oxide becomes a black solid. Now we keep doing this until the volume of air in the syringes does not change or remains constant. This is because the oxygen will be used up by the copper until it has used up all the oxygen in the air, and then the volume of air will remain constant. So I can use that to determine the percentage of oxygen in air. To prepare oxygen gas, we prepare oxygen gas from hydrogen peroxide solution. We said that hydrogen peroxide solution is something that decomposes to give oxygen gas. We add manganese dioxide to it because this acts as a catalyst and speeds up the reaction. You should know that oxygen is only slightly soluble in water, so we can collect it over water. Okay, let's talk about air pollution. What are the gases that we should talk about when we talk about air pollution? Carbon monoxide, sulfur dioxide, and oxides of nitrogen. First of all, we remember that carbon monoxide, we said, is a gas that is formed from incomplete combustion of fuel. So when we burn a fuel in lack of oxygen, we don't have enough oxygen, so we call that incomplete combustion of fuel. It forms carbon monoxide gas. And the problem with carbon monoxide gas is that it is toxic. And if he asks why it is toxic, we say because it reduces the capacity of blood to carry oxygen. Reduces the capacity of blood to carry oxygen. Then we have these other two gases are gases that cause acid rain. So you should know that sulfur dioxide and oxides of nitrogen are gases that cause acid rain. Sulfur dioxide is formed from the combustion of fossil fuel because the fossil fuels have sulfur impurities. So when you burn the fossil fuel, the sulfur in them burns and forms sulfur dioxide. When this sulfur dioxide gas goes up into the air, it causes acid rain, and actually acid rain has many bad effects, which we will discuss in a minute. The other gas that causes acid rain is oxides of nitrogen, and it comes out from car exhaust. So let's talk about this in detail. Now, we said, first of all, acid rain is caused by which gases? Sulfur dioxide gas from factories and oxides of nitrogen from car exhaust. So remember that sulfur dioxide gas from combustion of fossil fuels in factories, or nitrogen dioxide gas from car exhaust. Now, the sulfur dioxide gas, you should realize, first of all, that when sulfur burns, it burns with a blue flame to form sulfur dioxide. So sulfur burns in air with a blue flame to form sulfur dioxide. The coal, or the fossil fuel that contains sulfur impurities, when we burn it, it also gives sulfur dioxide gas. So sulfur in oxygen gives sulfur dioxide gas. Now, this sulfur dioxide gas will dissolve in rainwater, or it will become oxidized. So if the sulfur dioxide gas dissolves directly in rainwater, it forms sulfurous acid. So remember, if SO2 dissolves in water, it doesn't form sulfuric, it forms sulfurous, which is H2SO3. Now the sulfurous acid now, either it will be oxidized in air to form sulfuric acid, or the sulfur dioxide itself is oxidized in air to form sulfur trioxide. Now, when sulfur trioxide dissolves in water, this forms sulfuric acid. So I want you to remember that. When sulfur dioxide gas dissolves in water, it forms sulfurous acid, H2SO3. Now, when the SO3, sulfur trioxide, dissolves in water, it forms sulfuric acid, H2SO4. Oxides of nitrogen, we said also these cause acid rain, but where do they come from? We said they are formed in car engines. This is because the high temperature in the engine causes nitrogen and oxygen gas in the air around the engine. Remember that we're sitting with air around us that has nitrogen and oxygen that are just sitting next to each other doing nothing, because nitrogen is not really reactive. But when it is subjected to high temperature, or if we subject it to the electric spark during ignition of the car engine, then the nitrogen and oxygen gas in the air around the engine react. And when they react, they form oxides of nitrogen, and these are released from the car exhaust. So remember that oxides of nitrogen can be released from car exhaust, and they can also be formed in factories and fires because there is high temperature that would cause the reaction of hydrogen and oxygen in the air. All of this goes up into the air and forms acid rain. Remember, the oxides of nitrogen in the end will form which acid? They will form nitric acid. The oxides of sulfur in the end will form sulfuric acid. Now, when this goes up and dissolves in rainwater, this is what we call acid rain. So the acid rain falls on the environment, and it has many bad effects on the environment. So if we say what is the effect on buildings, we say acid rain dissolves the limestone in buildings and statues, and this causes them to crumble. If we say what is the effect on marine animals, it makes the water in rivers and lakes acidic, so it kills the marine animals. What is the effect on plants? It destroys the leaves and the roots, so it kills plants, and it can destroy whole forests uh, due to the presence of acid rain. Now, if he says what is the effect of acid rain on health, then we say it damages the respiratory system, or it damages the lungs, because when we breathe in air that has acid, this will damage the lungs. How do we prepare carbon dioxide gas in the lab? Remember that carbon dioxide in air is 0.03 or 0.04%. But we can prepare it in the lab. When we prepare carbon dioxide, we make it from the reaction of acid with carbonate. So I can use dilute HCl and marble, and we will say that marble is actually calcium carbonate. And then we can collect the carbon dioxide gas. How do we collect the carbon dioxide gas? These are the three methods of collecting gas. If we say we want to collect a gas, I can either collect it by one of these three methods or with a gas syringe if I want to measure the volume. So, which of these can be used to collect carbon dioxide gas? First of all, I cannot use water. I cannot collect carbon dioxide gas over water in that apparatus on top because carbon dioxide gas dissolves in water. So if he, in any experiment, he's saying that he's collecting carbon dioxide over water, now why is the volume of water less than expected? Well, because some of the carbon dioxide gas dissolved in the water. So I cannot use that apparatus on top. I need to use one of the ones below. Remember that the one on the left is called upward delivery. The one on the right is called downward delivery. Which one should I use for carbon dioxide gas? Remember that carbon dioxide gas is denser than air or heavier than air, so I have to collect it by downward delivery. What do we use carbon dioxide gas for? Well, we use it to make soft drinks. And if he says, what is the property of carbon dioxide gas that allows us to use it in soft drinks? It is the fact that it dissolves in water to form acidic solution. I will remind you that carbon dioxide gas, when it dissolves in water, it forms an acid called carbonic acid. So this is the one that gives the soft drinks their sour taste. We also use it in fire extinguishers because it is denser than air. So when you spray the carbon dioxide on the fire, it is denser than air, it settles over the fire and prevents reaction of the fire with oxygen in the air. So if he says, give a reason why carbon dioxide gas can be collected by downward delivery, we said we have to collect it by downward delivery. Why? Because it is denser than. If I say give another method of collecting the carbon dioxide, we said if I don't collect it by down delivery, I can collect it using a gas syringe, especially if I want to measure the volume. Then he says when carbon dioxide dissolves in water, a weakly acidic solution forms. So it forms a weak acid. What do you think the pH of that solution would be? If it's a weak acid, well, you can say pH 4 or pH 5 or pH 6, but nothing more or less than that. Then he says, suggest two properties of carbon dioxide that make it suitable for use in fire extinguishers. We said, why do we use carbon dioxide in fire extinguishers? Because it does not burn, first of all, and it is denser than air, so it will cover the fire and prevent it from reacting with oxygen. This is another typical question. He can say the word equation for the reaction is this, right? A chemical equation for the reaction. Of course, you should remember that carbonates react with acid to give salt, plus carbon dioxide, plus water. So here he's saying calcium carbonate with nitric acid will give calcium nitrate plus carbon dioxide plus water. Remember, you never leave an equation without balancing. So this needs a 2 in front of the HNO3 to balance. Then he says, a student needs to prepare and collect some carbon dioxide gas using the reaction between marble chips and dilute nitric acid. Now, state two reasons why the student's setup is not suitable for collecting carbon dioxide. Can you see the experiment? This kind of apparatus is not a good idea to collect carbon dioxide. Why? You should realize that, first of all, the gas should be collected by downward delivery. The gas jar that is up there, that is upward delivery. The carbon dioxide is heavier than air. It wants to go down, not up. And of course, can you see the thistle funnel? The thistle funnel is open, so the gas will escape through the thistle funnel instead of collecting in the gas jar. Okay, the other thing that we need to talk about is carbonates. And you already know what is test for carbonates. Test for carbonate is I add dilute hydrochloric acid, I get bubbles of gas that turn lime water milky. Remember that carbonates with acid give carbon dioxide gas. So if we're saying the test for carbonates is add acid and then bubble the gas through lime water, it turns milky. If we're just testing for carbon dioxide gas, then we just say bubble the gas through lime water, it turns milky. You should know what is limestone, marble, chalk, lime, slaked lime, and lime water. Remember that if we say limestone or marble or chalk, all of these are different forms of calcium carbonate. So if I say, what is the chemical name for limestone? The chemical name for limestone is calcium carbonate. Or if I say, what is the common name for calcium carbonate? It is limestone. Now, CaO is calcium oxide. So the chemical name is calcium oxide. But the common name is lime. So you should be aware that lime is calcium oxide. Now, lime water or slaked lime is calcium hydroxide. So the lime water that we use to test for carbon dioxide gas, if he says what is lime water is actually calcium hydroxide. You have to be aware of all of this. Now, if I start with limestone and we said limestone is calcium carbonate, how can I get slaked lime from it? You need to know this. The calcium carbonate is limestone. Now, if I heat it, this is thermal decomposition. Remember what is thermal decomposition? Breakdown of a substance using heat. The limestone, which is calcium carbonate, breaks up to form calcium oxide, which we call lime, plus carbon dioxide gas. Now, I can take this calcium oxide and dissolve in water. It forms what we call slaked lime or lime water. So the lime water that we have is actually calcium oxide dissolved in water. So a question like this, a clear solution of slaked lime is made by dissolving calcium hydroxide in excess water. This solution is left exposed to air. The solution slowly goes milky as a faint white precipitate forms. Explain why a white precipitate forms. Of course, we said calcium hydroxide or slaked lime, this is what we call lime water. Now, the lime water, when we expose it to the air, the carbon dioxide in the air will dissolve in it. And when carbon dioxide reacts with calcium hydroxide, it forms calcium carbonate. And you should know that calcium carbonate is something that does not dissolve in water. So this is why the lime water turns milky. So the solution of slaked lime or lime water reacts with the carbon dioxide in the air to form calcium carbonate, and calcium carbonate is insoluble, so it forms a white precipitate. This is another question. Air is a mixture of gases. The table gives the formula of 3 gases and their approximate percentage by volume. And he says, give the names of the 2 main gases in this sample of air. Of course, the 2 main gases in air are nitrogen and oxygen. Then give the name of the gas that makes up most of the remaining 0.96% of air. We said the rest of it is argon. State a use for nitrogen. What do we use nitrogen for? You should remember we use nitrogen to make ammonia, and ammonia is used to make fertilizers. Give the name of a gas present in polluted air that causes acid rain. Which gas causes acid rain? Well, you can say sulfur dioxide or oxides of nitrogen. Another question says, when an excess of carbon dioxide is bubbled through lime water, reaction 1 occurs. So he has lime water, which is calcium hydroxide. It reacts with carbon dioxide. It gives calcium carbonate, and we said this forms a precipitate, so it makes the lime water milky. But then you should realize that as I continue to pass carbon dioxide through the solution, the precipitate will actually disappear. This is because as we pass more and more carbon dioxide, the carbon dioxide will actually react with the precipitate, with calcium carbonate, to form calcium hydrogen carbonate, so it dissolves. So if you pass too much carbon dioxide through the lime water, first it becomes milky because it forms calcium carbonate, but then the precipitate will become clear, or the solution will become clear, because the reaction again with carbon dioxide forms calcium hydrogen carbonate. So he says, so just two observations that would be made when excess carbon dioxide is bubbled through lime water. We said if we start to bubble carbon dioxide through lime water, the lime water turns milky. And then more and more carbon dioxide will react with this precipitate that makes it milky, which is called calcium carbonate, and everything will dissolve, so everything will become a colorless solution. Carbon dioxide is used in some fire extinguishers because it does not support combustion. State another property of carbon dioxide that makes it suitable for use in fire extinguishers. Why do we use carbon dioxide in fire extinguishers? We say it is because it's denser than air, or more dense than air. This is another question. It says carbon dioxide is slightly soluble in water. The solution formed has a pH of 5.6. Which is the best description of a solution of carbon dioxide in water? If I tell you that the solution has a pH of 5.6, what does that tell you? That it is weakly acidic. Remember, carbon dioxide dissolves in water to form a weakly acidic solution. Then air is a mixture of gases. The two main gases present are the elements nitrogen and oxygen. Another element that is present is which one? We said the elements in air are nitrogen and oxygen and argon. Please remember, first of all, carbon dioxide is not an element. Sulfur dioxide is not an element. And please remember, air does not contain hydrogen. There is no hydrogen in it. Then he says, give the formula of a compound that is found in unpolluted air. So normal air, I need a formula of a compound. Well, you can say either CO2 or H2O because we have carbon dioxide or water. This apparatus in the diagram is used to find the percentage of oxygen in air. The large pile of copper powder is heated and the air in the syringe is passed several times from one gas syringe to the other. So this is the experiment we were talking about. The large pile of copper powder turns black. The remaining gas is allowed to cool and its volume is measured. Explain why the large pile of copper turns black. We said what happens to the copper? It reacts with oxygen in the air to form copper oxide, and copper oxide is black. Why is the gas allowed to cool before its volume is measured? Remember, when we heat any gases and we're trying to determine volume, we have to allow the gases to cool before we determine the volume. This is because gases expand on heating. So if I take the volume when it is still hot, the volume would not be accurate. The small pile of copper powder is then heated and the remaining gas is passed several times over the hot copper. The copper does not turn black. So he's trying to pass more and more of the remaining gas over the copper. That's it. It doesn't turn black. So just why the small pile of copper does not turn black, of course, this is because we have already used all the oxygen, so no more copper reacts. In another experiment, the total volume of air in the apparatus before heating is 150 centimeter cube. At the end of the experiment, the volume of gas remaining is this. Use this information to calculate the percentage of oxygen. How do we get percentage of oxygen? Of course, if I'm starting with 150 and the volume of the gas at the end is 125, then the difference is the volume of oxygen. Now, to get percentage, it is that difference over the original times 100 that gives me the percentage of oxygen. Okay? Another question says this apparatus can be used to prepare carbon dioxide from reagents A and B. So he's saying calcium chloride and water are products. So what do you think A and B are in order to give carbon dioxide gas and calcium chloride and water? That means we said, first of all, we need an acid with a carbonate. So which acid should I use? He's saying it will give calcium chloride. That means I need the acid that has chloride, so hydrochloric acid. And then it will give calcium chloride. That means that the carbonate has to be calcium carbonate. In the diagram, the carbon dioxide is collected over water. State another way of collecting carbon dioxide. Of course, we use a gas syringe. At the end of the experiment, the solution in the trough is weakly acidic. State the color of the solution when some universal indicator is added. You should remember universal indicator in weak acid will have what color? Orange or yellow. Give the names and the formula of the acid that forms when carbon dioxide dissolved in water. Do you remember the acid? I said when we dissolve carbon dioxide in water, it gives which acid? It gives carbonic acid. How would we write the formula of carbonic acid? Carbonic acid is the acid that has carbonate. So that is carbonic acid. This apparatus is used to determine the percentage of oxygen in air. A teacher sets up the apparatus and records the initial volume of gas in the tube. When the level of water in the tube becomes constant, he records the final volume of gas in the tube. Now, so just the time taken for the volume of gas in the tube to become constant. What is happening in the tube? I have iron reacting with oxygen in the air. How long would iron take in order to rust? This is rusting of iron. How long would the rusting take? Remember that the rusting is a slow process, but it's not too slow, but it is a slow process. So it will not take 1 second or 1 minute. It will probably take 1 week. And usually when we explain experiments involving rusting, we say we're going to leave it, for example, for 5 days. Okay? Other than changes to the levels of the water in the apparatus, state one other observation that would be made at the end of the experiment. Of course, I have iron wool at the top of the tube. What will happen to that iron wool? The iron wool would rust, and we know that rusting means it will turn into reddish brown or brown. The teacher adjusts the apparatus before recording the volume of the gas. Explain the change that he makes. Why does he need to adjust the apparatus? What does he have to do? Well, obviously the tube is bent. You can't measure volume with the tube like that, so you have to hold the tube upright to record the volume accurately. The teacher does the experiment 4 times and he has these results. Calculate the percentage of oxygen in air in the first experiment. Again, how do we calculate percentage of oxygen? We see the difference over the original times 100. So the difference, he started with a volume of 32 and ended with a volume of 26. The difference over the 32 times 100, this gives you the percent of oxygen in the air sample. Although the mean percentage of oxygen in these experiments is 19%, the teacher states that this value may not be accurate. Why do you think this value may not be accurate? Well, remember, the volume changes in this experiment is small, and when we have very small readings, we are likely to have a high percent error, so any slight difference in the reading will give a different result. So the accuracy is not very good in this experiment. Okay, so the temperature, or we could say the temperature may not be constant, so the volume of gas may change. That's another possible answer to that question. Then the question says, explain the effect, if any, on the calculated percentage of oxygen in air when these changes are made. Okay. What if the iron wool is left for a shorter period of time? What effect would that have on percentage oxygen? Well, if I leave it for a shorter period of time, then the percentage oxygen that I calculate will be smaller because not all the oxygen in the air has reacted. What if I put a larger piece of iron wool in the test tube? Well, there will be no change because in that case, if I use too much iron wool, it will just be excess. It will use the amount of oxygen in the air and then no more reaction. Okay, so that is the end of this chapter. I hope this was useful and thank you for listening.